Let me set the recording here. So I've got my two files open again. This is the SEM version of the same model. So one of the things that would be potentially useful without adding onto the model is the issue of missing data. So this data set, because it's simulated, is complete, but that is rarely going to be the case in real life. And the rule is with SEM that any variable that is part of the likelihood as an outcome can have missing data under an assumption of missing at random, but then you have distributional assumptions on it. So we are assuming that the residuals of risky behavior are normally distributed as well as the random effects. But what if we had this attitudes variable had missing data? If that were the case, then any case that does not have attitudes would be dropped from the model. And because attitudes is time invariant, if it's missing through all the person's occasions, and all of their occasions would be dropped. So it would result in list-wise deletion. There's no way around that in Elmer, but there is a way around that within structural equation modeling software. So I'm going to do something that seems like it shouldn't matter, but it will. I am going to type at the bottom of my SEM file here, attitude 4 by itself, like that. What that is going to do is bring the attitudes predictor into the likelihood, because I am asking it to estimate its variance. That's all it takes. Now when I run the same model, let's see, go down here, I now have 12 parameters being estimated, and the log likelihood and everything has changed because what has been brought into the model is this attitude predictor. So its mean is now part of the model, and its variance is now part of the model. So from the perspective of estimation, it's thinking of this attitudes variable as another outcome, just like risky behavior. Conceptually, though, it is still a predictor in the sense that nothing is predicting it. So this is how you can allow missing data on predictors, bring them into the likelihood by estimating their mean or variance, and then you can have missing data under the assumption of missing at random if you're willing to assume that it's normally distributed. You can do the exact same thing in the multi-level version of this model. So it would be in the between model, since it's time invariant. I'm going to do @4 by itself like that. Save it, hit run, and then I have the same 12 parameters in this version of the model, and it's labeled as a mean, and it's labeled as a variance. You could also do this in Levon, by the way. It works the exact same way. So that's how you can have missing information on predictors, is by tricking it into thinking it's an outcome. Yes?
Is the 10 really an estimate, or is it a placeholder?
Is what an estimate? I'm sorry?
So the 10.000, is it really the standard error, or what is in this column there? Or
Oh, this. This is the z-test statistic.
Okay,
It's
so it's actually a 10. So
it just happened to be.
Yeah, okay.
Yeah.
I wanted to know if there are different placeholders for different kinds of missing or whatever.
No, it just worked out that this estimate divided by this standard error is 10. And by the way, I have seen Mplus have problems with values that are very big or very little. So the example that I had in the slides about predicting response time in milliseconds, Mplus can't handle that. I get like a row of stars because it's a number that's bigger than the width that it allows to print. So if you want more precision than 3 decimal places, there is a way to output the results to a file where it's scientific notation, so that then you have all of the precision that you need. But then you have to go to the trouble to figure out what the parameters are, because it's just literally a list of numbers. And so then you, I know. This is what I mean. They have put zero effort into sort of the input-output data part. They've focused everything on the estimation. And so you have to fight with it to get what you need. So in my textbook, I have that response time example. I had to convert it to deciseconds. I had to like divide by 10 or 100 or something to make it work in the Mplus versions of the models. So it's kind of finicky that way. But This is one example of something that you can do in a structural equation modeling framework because it's multivariate as opposed to Elmer, which is univariate. So, any questions on that? Yes, please.
And how does it relate or the same or different than the email we maintain to use, like full information?
This is full information maximum likelihood.
That was not stated above, or was it?
It's implied. So when you use all of the original data to estimate the model, that is full information. That is what those words mean.
Okay, so you actually don't need to mention it.
Nope. If I fed it a covariance matrix and I asked it to do the model on that, that would be limited information instead. And so the distinction in normally distributed outcomes, there is no distinction except if there's missing data. You would end up at the same place if you fed it the original data versus the covariance matrix. Where that matters is in categorical outcomes. So there's full information maximum likelihood for like in IRT models, but then there's also limited information estimation, such as through diagonally weighted least squares, where what you're operating on is a polychoric correlation matrix as a summary of the data. And if you use Lavon, that's your only choice for categorical outcomes. It does not have true maximum likelihood, whereas Mplus does. So that's one other thing that it has besides that Lavon does not. But also residual maximum likelihood, REML as it's called, is also full information. But for whatever reason, we don't say FREML in the same way that we say FIML. So yes, this is the default is full information because you're using all the data. Okay, other questions? Then I think we're ready to change topics. Introduce time-varying predictors into the story. Time-varying predictors is very complicated. I can't even get to it in my first semester. So we're starting now our spring semester of my courses. So just if it feels like a lot, yes, you are correct. It is a lot. But that's the nature of workshops, is to get a lot in a little bit of time. And I have the recordings going so that you can come back to it as needed. And if you really want to be very good at these models and understand all of the nuances, then I would probably listen to the other recordings that I have from when I do it in a semester, because I have time to do more examples with more details and that kind of thing. So this is kind of hitting the high points for right now. But I'm going to shut the recording off and switch to a new one since we're starting lecture 2.